Hello everybody. This is a problem about a uniform probability distribution. Okay, let's read the problem. It says, the uniform probability density of a random variable x is given in the figure below. The graph of a uniform density curve is always a horizontal line. So yeah, a uniform probability distribution, the curve that represents it is called the density. And if it's uniform, it means that every outcome is equally likely. And that makes the curve go straight across horizontally. If some outcomes were less likely than others, this curve would dip down over there. And if some outcomes were more likely than others, the curve would go up over there. But since all outcomes are equally likely, the curve just goes straight across. And that's what it means to be uniform. Okay, it says, since the total area under the probability distribution curve is blank, the height of the curve must be blank. Well, you should know from your readings on this material that the total area under any probability distribution curve, anywhere, is always 1. It's always 1. The height of the curve must be blank. Well, okay. We know the area of this is 1. So what does the height have to be? Well, we have a hint here. Recall that the area of a rectangle is width times height. So we know that width times height has to be equal. Sorry, I'm off the screen. We know that width times height has to be equal to 1. And we happen to know the width of this curve. It's 2. So we know 2h equals 1. So we can solve this for h. If 2h equals 1, divide both sides by 2, we see that h has to equal 1/2. So that answers this question. The height of the curve must be 1/2. Okay, let's move along here. The probability that x is no more than 0.3 is blank. Okay, well, let's look up here in the picture. Where's 0.3? 0.3 is about a third of the way to 1, so 0.3 is about here. There it is. So the probability that x is no more than 3. Well, more than 3 means over here. No more than 3 means the other direction. So we're over here somewhere. What's the probability of a value of x falling in this range? Well, we know that the probability is given by the area under the curve. So all I do is find this area. Now that's the area of a rectangle. So again, we can go to this formula over here. The area of a rectangle is width times height. So the area of this rectangle is, well, the width is 0.3. And we said the height of the curve was 1/2. So therefore, the area is 0.15. That's half of 0.3. So 0.15. Now, what's the probability that x is at least 0.3? Well, at least 0.3 means 0.3 or greater. So that means we're finding the area of this rectangle over here. Okay? So how do I find its area? Well, one way to do it is to measure the distance from here to here, measure its width, and then multiply it by the height, which is 1/2. But there's a quicker way to do it, because you see that this being at least 0.3 is the opposite of being no more than 3. Being over here is exactly the opposite of being over here. And we know how the probabilities of opposites relate. Sometimes we call these complements. We use the complement rule. And we know that the probability of x being at least 0.3 is 1 minus the probability of its complement. It's 1 minus the probability that x is less than 0.3. And we computed this before. That's what was 0.15. So this is 1 minus 0.15, so that is 0.85. So that's the answer here. 0.85.